students, good morning. Today we will discuss about radiocarbon dating under nuclear chemistry. Okay, so radiocarbon dating, it is nothing but the method of estimating the age of antiq, that is ancient material. Either it may be a part of wood or wood piece, or say parts of dead materials, okay, or dead animals, fossils like that. See, in this method, the main principle is the radioactive carbon, which is C14. It is beta emitter. It is a radioactive element which emits beta radiations. Okay. So now, if we know the amount of C14 present in the dead and comparing it to the amount of C14 in the live or living organisms, one can calculate, say, the age of that material. Okay, so now in order to do so, in order to understand how the C14 is obtained in the atmosphere, say, in the atmosphere, cosmic radiations which are coming from the stars, they are having or constituted with, say, the energetic elements like hydrogen or H plus or helium ions. Okay, when they interact with the stable nuclei present in the atmosphere, they release or produce neutrons. Okay, they produce neutrons, and such neutrons, along with other products, such neutrons, when they interact with the N14 which is present in the upper atmosphere, it gives radioactive C14. Say N14 present in the upper atmosphere reacts with the neutrons, okay, and thereby produces C14, that is radioactive carbon, and which is a beta emitter, and which is having T half is nearly 5730 years. Okay, so now say the C14, which is, now you are well familiar, C12 is very abundant in the atmosphere. It is above 99% of C12 is present, and the C14 is present in a tracer amount, and that amount of C14 in the atmosphere which undergoes oxidation to produce carbon dioxide. So along with which, or with this, there is an abundant amount of C12 in the form of carbon dioxide. Okay, C12, that means carbon with 12 atomic mass, that also forms carbon dioxide. Okay, that is plenty, that is in abundance. See, now when the plants absorbs carbon dioxide from the atmosphere during photosynthesis, say they produce the food, that is carbohydrates and etc. Okay, and the from plants, animal will eat, it will enter the animals through food chain, and when they respirate, it once again goes back to atmosphere. So say the carbon dioxide, okay, which contains both C12 in maximum amount, C14 in trace amount. So when they inhale, when they absorb, either say animals or say plants during photosynthesis, say once again it enters back to atmosphere. Okay, and it is a constant in living organisms. It is a constant in living organisms, and which is exactly same as that in atmosphere. Okay, once the material or the animals die or the plants die, so what happens in the dead material, say the C14 amount will goes on decreasing, and C12 remains the same unchanged, and because it undergoes decay, and the amount of C14 is goes on decreasing. Okay, so thereby knowing the amount of C14 in the form of carbon dioxide or carbon which is present in the dead material and comparing it with the atmospheric, so one can calculate the age of that material by using this formula. So this is familiar to you. T is the time period, 2.303, that is equal to 2.303 divided by decay constant log of N0 by N. N0 is initial amount, N is the amount present after the time t. So now say by using this formula, by putting, say, as you know, decay constant, it is related to 6.693 by t half, and inserting that value here. So rearranging the terms we get here, or the final it is like this, or it is simply the age of any material can be calculated by using this formula, and where 2.303 by 6.693 into half-life of 14 C14 into log of amount of C14 in living divided by amount of C14 in dead. So by using this formula, one can calculate the age of antique. Okay. So there are two problems. Say in one they have given a piece of wood, okay, which is having C14 to C12 ratio is 0.7 times that of living, and T half of C14 is 5760 years. So they are asking what is the age of that piece of wood. So by using this formula, by putting all these things here, and the amount of this ratio of the piece of wood, it is 0.7, that is amount of C14 in dead is 0.7. The time they have given 0.7 times means it is 1. So by calculating, you are getting the age of that wood is 2970 years. Similarly, another problem, the ratio, say the C14 to C12 ratio of a wood is 13% of the atmosphere. Calculate the age of wood. They have given T half of carbon 14, that is 5580 years. So by putting the same, say here it's 100, and they have mentioned it is 13%, and the result is that wood piece is 16,430 years of age. Okay, so like this we can calculate, say, the age of the either wood piece or any rock or monuments, isn't it? So any ancient, say, materials, antique materials, ancient materials, by using this radiocarbon dating. Very clear? Okay, with this, say the nuclear chemistry chapter is over, and in the next class we'll start with, say, inorganic polymers. Thank you.